We're going to continue in section 6.1 talking about greatest common factors. And if you remember in our last video, we closed with the idea of finding the greatest common factor between three terms. And those terms may be just numbers, it may be numbers and letters combined, but we need to be able to find the greatest common factor. And so that then leads into how we're going to factor polynomials. The first way we're going to factor polynomials, and that is by finding the greatest common factor. So here's how it works. We're going to take this binomial 4x squared plus 6x, and we're going to first identify what is the greatest common factor between both of those terms. Well, hopefully you look at that and you know that 2 goes into 4 and 6, and you see an x in both terms, and so 2x must be the greatest common factor. Now, here's how this works. We're going to bring that out to the front, and we're going to open a set of parentheses. Then we're going to divide that 2x out of each term, and whatever's left goes in the parentheses. So, for example, 4x squared divided by 2x is going to be 2x. Again, it's just a quotient rule. If you go back to section 5.7, we divided binomial by monomial, or polynomial by monomial, and we divided each term by that one monomial. Well, that's the same thing we're doing here. And so then divide 6x by 2x, and we get 3. And so that 2x plus 3 goes in parentheses. That 2x plus 3 is a factor. The 2x is a factor. So remember, factors are a collection of things being multiplied together. So 2 is a factor, x is a factor because it's 2 times x, and then 2x plus 3 is a factor because it's 2x plus 3 times the 2x. Okay, so 3 factors that are in this binomial once it's been broken down. And so that is how we're going to find the greatest common factor. And this is always the very first thing we try. We always try to take out a greatest common factor first. Sometimes there's not one. Sometimes we can't do this. But if we can, this is the first thing we do each time. Okay? Now, we go to the next problem. We've got m to the 7th plus m to the 9th. Very similar situation here. We're going to take out or factor out whatever those two terms have in common. Well, you'll notice that they both have 7 m's, or m to the 7th, right? And so when we factor that out, m to the 7th divided by m to the 7th is 1. If you do not put the 1, it's wrong, okay? Got to have that 1. And then m to the 9th divided by m to the 7th is m squared. Now, here's a little tidbit. When you take out the greatest common factor, if you started with 2 terms in the original problem, you better end up with 2 terms in that parentheses. Okay? If you don't have 2 terms, it means you left out probably a 1 in most cases. So make sure that you do get that that set of parentheses correct. It's not enough just to say, oh, well, the common factor is m to the 7th. But we got to know when we take it out what's left. Essentially what you're doing here is you're undoing the distributive property. It actually is the distributive property, but it's opposite of what we typically think about. We typically think about being able to take a number and distribute it into the parentheses. Well, now we're just taking it back out. In fact, back in chapter 1, we talked about the distributive property. We talked about how you can put something in. You can multiply, for example, 2x times 2x and then 2x times 3. Or you could even take that common factor, what they had in common, out. And so we did this back in chapter 1. But now, obviously, we're going to add to it a little bit and get into some more detail. Now, if you have questions about that, obviously let me know. I'll be glad to answer any questions you have. But look at the next one. In fact, I'd like you to try this next one on your own. So pause the video, try this one, come back when you get done. So hopefully you did that. You paused the video and worked this one. And if you take out the greatest common factor, don't just tell me it's 2. Okay? make sure you tell me the whole common factor. So in this case, it's 2y squared, because 2 does go into 10, 8, and 6, but then there's 2 y's in every term. And so 2y squared is that common factor. Now, when you divide that out, what's left is 5y cubed minus 4y squared plus 3. And notice there's not any y's in that last term because we took them out, right? So I always have people ask, well, how do I know what goes in the parentheses? Well, here's what you do. You're dividing the numbers, so you can see 10 divided by 2 is the 5. 8 divided by 2 is the 4. 6 divided by 2 is 3. As you do that division, you're just going to, all you do here is simply divide those numbers. And then with the exponents, you just subtract. So you had 5, you took out 2, there's 3 left. And then with the second term, you had 4, you took out 2, there's 2 left. The last term you had 2, you took them both out, so there's no y's left in that last term. Okay, so that is our process for finding the greatest common factor. Again, if you have issues about that or any questions or anything, let me know. I'll be glad to help you. Now, look at the last one. We have, again, this polynomial, it does have some things in common. So we want to take out the greatest common factor. And when you look at this, some of you may think from a number standpoint that it's 2. And 2 is a common factor, but it's not the greatest common factor. The biggest number that divides into 8, 16, and 12 is 4. Because 8 is 4 times 2, and 16 is 4 times 4, and 12 is 4 times 3. And so 4 is the biggest number that we can take out. Now we still got p's and q's, and we need to take those out as well. So we're going to take the 4 out. There are 4 p's in each term. So this one has 5, this one has 6, this one has 4. So there's 4 in each of those. And then for the q's, there's 2 here, 3 here, 7 here. So they all have 2 q's. And then again, we're just going to divide that out. So 8 divided by 4 is 2. The p to the 5th, you had 5, took 4 out, there's a p left. There were 2 q's, you took them both out, there's no q's left. So go to the next term. 16 divided by 4 is 4. There were 6 p's, you took 4 out, there's 2 left. There were 3 q's, you took 2 of them out, so there's 1 q left. And then the last term, negative 12 divided by 4 is negative 3. There were 4 p's, you took them all out, so there's no p's left. There were 7 q's, you took 2 out, and so there's 5 q's left. So q to the 5th. And again, there's our factored form of that polynomial. When you finish this, you should have something being multiplied by something else. Okay? Now, let's try a few more here. So on this next one, it's the same exact thing. I am going to ask you in this one to factor out the negative common factor. And the reason we're going to do that is because that first number is negative. And sometimes that's an indication that you may want to factor out a negative. We'll talk about when you would want to factor out a negative later on. But for now, I want you to factor out the negative common factor. So when you look at that, you notice with the numbers, I hope you notice that 7 goes into all those, right? 14 is 7 times 2, and 21 is 7 times 3, and 7 is 7 times 1. And then they all have an A and they all have a B. But they only have one A and one B, right? Because this last term only has one A and it only has one B. So, our greatest common factor is negative 7 AB. Okay? And then we're going to divide that out. And so negative 14 divided by 7, negative 7 is positive 2. We took an A out, and so there's 2 left. Took a B out, and so there's only a B left. In the next term, negative 21 divided by negative 7 is positive 3. There were 2 A's, we took 1 out, so there's 1 left. There were 3 B's, we took 1 out, so there's 2 left. And then the last term, 7 divided by negative 7 is a negative 1. And then we had an A, we took it out, had a B, took it out. And so there is our final answer. Now, is it wrong to have taken the positive 7AB out? No, it's not. Your signs would have been changed in your trinomial. I want to take the negative out because there is going to be a need for that at times. Okay. Now, on these next three, we're doing the same exact thing. We're taking out the greatest common factor, but some of you may look at this and go, I don't know. This is just too confusing. I can't do it. So when you think about taking out the greatest common factor, what it means is we're taking out the factor the terms have in common. So when you look at this first term, now understand the difference between a factor and a term. And you may want to make a note of this somewhere. A factor, well, let's talk about terms first. A term is a collection of things that are being multiplied or divided together. Okay, it may be numbers and letters and exponents and all that stuff. Collection of those things being multiplied or divided together. They're separated, terms are separated typically by addition and subtraction signs. A factor are those individual pieces getting multiplied. So when you look at this next problem, there's actually only two terms. You have y squared times y plus 2 and negative 3 times y plus 2. Now, within that first term, there are three factors. You've got a y, and you don't have to write this out, I'm just doing it for illustration. You have a y times another y times y plus 2. Those are the three factors from that first term. That second term has a factor of negative 3 and a factor of y plus 2. Those are your only two factors. And so when you look at that and you say, okay, what factor do they have in common? Well, there should, I hope, be an obvious one, y plus 2. And again, it's not y and it's not 2. It can't be separated. It has to stay together. That is a factor, can't be broken down. It's not y and 2, it's y plus 2. Okay? And so that y plus 2 is our common factor. So just like we did in the problem above it with the negative 7ab, we're going to bring that y plus 2 out to the front because that's our common factor. And we're going to open a set of parentheses and put what's left. Well, when you've taken that y plus 2 out of that first term, what's left is y squared. And when you've taken it out of the second term, dividing it out, you're left with negative 3. Well, now we have two things being multiplied, right? Y plus 2 times y squared minus 3. And so this is our final answer. Now, one of the things about factoring that's good is that you can always multiply your answers together to see if it gives you what you started with. So, for example, in the first problem here, if you want to take negative 7ab and distribute it, you would see that it gives you what you started with, that trinomial on the top. Well, this is a little more difficult to do, but if you could think about distributing this y plus 2 all at the same time, and you distribute it to the y squared, well, y plus 2 times y squared is going to be this term. And then if you distribute it to the negative 3 times y plus 2 is that term. And so you could technically distribute this back and be able to get your answer. So here's the very simple version of this. Whatever's in parentheses is going to be your common factor, typically. That's what you're going to bring out to the front. Everything else will go in parentheses together. So you see that's what we did here. We took the y plus 2 out of both terms, brought it to the front, and then what was left was the y squared and the negative 3. That went together in the other parentheses. Okay, so that's all that's happening. And if you can do this, that's going to lead into our next method of factoring, which we'll see in our next video. But you've got to be able to do this to do that. So if you look at the next one, the common factor between those two terms, again, there's only two terms, right? R times t minus 4 is a term. 5 times t minus 4 is a term. The factor they have in common is t minus 4. And so when you divide that out of each term, what's left? Well, r plus 5. And so there's our final answer. And then if you look at the last one, same thing. The common factor is x minus 1. Oh, sorry. Let's see if I can get all that back up. There it goes. So x minus 1 is the common factor. And then what's left is x minus 5. Again, not a difficult process once you understand what's happening with that. Hopefully you can do that pretty easily. If you have questions about it, again, let me know. Shoot me an email, and I'll try to answer any questions that you have. We'll stop the video here. We will continue in our next section, or the next part of this section, in our next video.